Hello everyone, in this video we're going to be solving a Sangaku problem, which are also called Japanese temple problems. The radii of three circles are given in numerical order, x, y, and z. We're supposed to find the radius of the largest circle, x, in terms of y and z. So at this point you can go ahead and pause the video and try the problem yourself first. Okay, so we're going to start by marking the centers of each circle, and then we'll be connecting them. So let's go ahead and connect those centers. 1 and 2, 3 and 2, and then 1 and 3. Okay. And then of course we're also going to be making some vertical lines here. So we can go ahead and connect these two lines with a vertical segment like this. Those are going to be perpendiculars, obviously. And another one here we can make. Okay, so those are going to be at 90 degrees. And then we can connect these two parallel segments with a horizontal line like this one. That'll help us build the equations that come from Pythagorean Theorem. And then another horizontal segment here. Okay, all right, so this part is probably a little hard to see, but I hope you can see it from here. Okay, so let's go ahead and place the mark the radii here, the largest one being x. So this would be x, this would be a z, this would be a z again, this would be y, and this would also be y. Okay, so let me go ahead and use a different color here for this one. Maybe we could probably make a blue one. Yeah, right there. Okay, let me go ahead and make a blue connection here so you can see the outside as well as this one. Okay. All right, there we go. Okay, now what I'm going to do is I'm going to be using these right triangles here to find the relation between x, y, and z. Okay, so these are 90-degree angles. Let's switch our same color. These are 90-degree angles. Okay, this would be like a 90-degree angle as well. Okay, and then we have a 90-degree angle here as well. Okay, now let's go ahead and designate these lengths. Now we know that the radius of the blue circle is y. So this is also going to be y. And as you know, this is the center for circle number 1, which is x. So this piece is going to be x minus y, this little tiny piece. Okay. And as you know, here, this segment connects these two centers here and here. So this will be x and this will be y. Therefore, this whole segment is going to be x plus y. And this is going to be x minus y. So that's going to allow us actually to find the length of the horizontal segment. Now let's take a look at this one. Now this is a little tricky. The radius for the, let me go ahead and draw this segment. So this is going to be z because it's the radius of the smallest circle. So this is also going to be z. And this one is also going to be z. Okay? All right. Cool. Now, what else can we do here? All right, we got to designate or actually determine this length as well. So what is this length going to be? And when I say that, I mean this length, right? I got to find that out. Well, that's going to be the x minus y, right? So this whole thing is basically, let's take a look at this one. Okay, so this is going to be, this whole thing between the two parallel lines is going to be 2x, right? Because the radius is x, so it's going to be diameter. So this whole thing is also 2x. So from 2x, you are subtracting y and z. So this piece is going to be 2x minus y minus z actually, right? That's probably one of the toughest parts. And this piece is going to be x minus z. So let's switch our white marker, x minus z here. And then what else do we know? This is x plus z here. That's z plus y here. so on and so forth. I think we have everything we need. We can just, go ahead and just go from here, okay? And of course, I need to designate some length so I can represent this in terms of a sum, okay? All right, so let's call this point A, and let's call this point B. My goal is basically to use the length of segment AB, okay? And I can find that length by using this right triangle here, this tiny right triangle, okay? So let's go ahead and write down the Pythagorean theorem on AB, and that's gonna look like AB squared plus x minus y squared is equal to x plus y squared. So AB squared is going to equal the difference of these two quantities. As you know, in our previous problems, we established that it's equal to 4xy. From here, I can find the length of AB. I don't know why I wrote those. I guess I'm just going to write it as AB. Okay. AB is going to equal 2 root xy. Okay. All right. So that's going to be the length of AB. Now what I need to do is use that sum use that length actually as a sum of two segments here. So this is what I mean. So if you call this point C, great, messed up our connection there. So if you call this C, and if this is a D, let's say this is point D, and this is point E, okay? I'm talking about CE plus ED being equal to AB, okay? Geometrically. So how do you find CE though? Well, CE is one of the legs of a right triangle. So let's go ahead and use the Pythagorean theorem on that one as well. So we can write it here as CE squared plus x minus z squared, okay? And that's going to equal x plus z squared. So similarly, we can find CE from here, which is going to be 2 times the square root of xz. Okay? That's another thing that we can find. Now we need to find ED. And as you know, ED is one of the legs of a right triangle, which I can go ahead and shade that here. And that would be, I can just go ahead and write down ED squared is equal to, ED squared plus, okay, ED squared plus DB squared, which is 2x minus y minus z squared, is equal to z plus y squared. Okay, so let me go ahead and write it down here. Maybe scroll down a little bit or up. Okay, so this was 2x minus y minus z squared, and that should equal y plus z squared. Okay, awesome. So basically, I got my 3 equations that I need, one of which is, let's see, one of which is this one, and this one. This one I haven't simplified yet, so let me go ahead and simplify that, and then I'll box it. So let's go ahead and write that down here, ED squared plus. Now, how do you expand that? Well, you can look at it as a difference or just square everything. I would like to treat it as 2x minus the quantity y plus z squared, because that'll make our life easier. Let's go ahead and do that. Okay, and then if I expand it that way, it'll look like this, 4x squared minus 4x times y plus z plus y plus z squared. And you're going to notice that the whole thing is going to cancel out on the right hand side, which is a good thing for us. And then if you go ahead and expand this, you can actually get the ED squared by itself. Okay, so ED squared is going to equal 4xy. I can just go ahead and write it down as 4xy plus 4xz on the right hand side, of course, minus 4x squared. And obviously we can pull out some terms here, such as we can actually take out a 4x here, and that'll give me y plus z minus x. Okay, so from here, ED would be the square root of that. Let's go ahead and write that down. And ED would be 2 times the square root of x times the quantity y plus z minus x. Okay? So that's going to be the third expression that I need. Now we do know that CE plus ED is equal to AB. Okay? So we're going to be adding the CE. Okay? Continue with this color maybe. CE plus ED, which is this one, right? And something nice is going to come out of this. You're going to notice in a little bit, is equal to AB. Okay. So what is so nice about this expression is that it kind of looks a little complicated, but we can simplify this further. How? Well, first of all, we can just go ahead and factor out a 2 times the square root of x, and then we can just go ahead and simplify it a little bit more. Okay? So let's see what happens if we do that. We're going to be pulling out a 2 times the square root of x, and then inside the parentheses, we're going to get root z plus root y plus z minus x, okay, on the left-hand side. And that is equal to 2 root x multiplied by root y. Okay, this is nice. We know that x does not equal 0, so we can just go ahead and cancel those out. And now I should leave that radical, this one, alone, so that I can just write it as, oh no. Okay, so I can just write it as the square root of y plus z minus x is equal to the square root of y minus the square root of z. Okay, then the next step obviously will be squaring both sides, and let's go ahead and do that. And we'll be getting something nice from here, hopefully, right? And remember, if you go back to the statement of the problem, our goal is to find x in terms of y and z because none of the lengths were given numerically, so our goal is to isolate x in this case. Okay? We're almost there. Just hang in. So I'm going to square both sides, and that's going to give me y plus z minus x, which is equal to y minus 2 square root of yz plus z. Again, this is going to have a happy ending. Y plus z is going to cancel out, and we're going to end up with this guy. And multiply both sides by -1 if you don't like the negatives like me, and then you'll be getting this. Okay? Now remember, our goal was to find x in terms of y and z, and we actually did. X is alone, all by itself on the left-hand side, and that's our answer. Thank you for watching. Thank you for your patience. Please subscribe, comment, and like. If you liked the video, let me know. If you didn't like the video, let me know. And see you in the next one. Have a good one. Bye-bye.